In this section, we'll discuss the effect of dielectric insertion in a capacitor. There are two cases we are going to discuss in it. Case 1 is the situation when a battery is connected to capacitor during insertion of dielectric. Here you can see the situation shown in figure. In this figure, we are given with a battery connected to a capacitor of plate area A and separation D. Here we know its capacitance we can write as epsilon naught A by D. And a dielectric slab is placed in such a way that we can easily insert it into the capacitor. Now, if we insert it into the capacitor such that it will completely fill the space between the plates, some parameters which are associated with the capacitor will change. Let's discuss on the variation in the parameters which are associated with the capacitor. Like if we talk about before insertion of dielectric, the capacitance of the capacitor, we know it was epsilon naught A by D. If we talk about the potential difference across the plates, this potential difference was V, which was maintained by the battery. The electric field between the plates of capacitor, we can write it V by D. If we talk about the charge on the capacitor, it was Q, which can be written as CV, which is the charge plus Q and minus Q on the plates. If we talk about the energy stored in the capacitor plates U, this can be written as half CV square, where V is the potential difference maintained by the battery and C was the capacitance. So now we'll discuss about these 5 parameters. What are the effects on these 5 parameters on insertion of a slab? So before insertion, say these parameters are C, V, we take charge, electric field E, and energy stored U. Now if we talk about after insertion of dielectric slab, if we just have a look on the change in the parameters about capacitance, we can say after insertion of dielectric, this capacitance will change to C prime, which will be K epsilon naught A by D. This we already studied, or it can be written as Kc. So we can say on insertion of dielectric, here C will change to Kc. If we talk about the potential difference, it will remain same as the battery is connected, which will maintain the potential difference. If we talk about the charge on capacitor in a steady state, it is given as Cv. So V here remains same, but C changes to Kc. So final charge will become Kq, because it will change from C to Kc. So the charge on capacitor will change from Cv to Kcv. If we talk about electric field, we can see the electric field between the plates is V by D. V remains same, D remains same, so there won't be any change in electric field. If we talk about the energy stored between the plates of capacitor, it is half CV square. Here V remains same, but C changes to Kc, so U also changes to Ku. So you must be very careful about these variations, because there are n number of numerical problems which are based on the parameter variations on insertion of dielectric slab associated with the capacitor. We'll also continue with the case 2 on the next sheet. Let's also discuss the second case of dielectric insertion in a capacitor. When battery is disconnected after charging the capacitor before insertion of dielectric. Here you can see a capacitor which is having again the capacitance given as epsilon naught A by D, and which is charged with the charge Q, and battery is disconnected after charging of capacitor. Now if we insert the dielectric slab in the capacitor such that it will completely fills the space between the two plates, again the parameters associated with the capacitor will change due to insertion of dielectric. Now we will study about these, and we can say about the parameters. If we talk about the parameters before insertion, these parameters R1, the capacitance we have seen it is epsilon naught A by D. If we talk about the charge on capacitor Q, it was CV, and here you can see the charge on capacitor will remain constant because no battery is present over here, so it will not change. If we talk about the potential difference across the plates, terminal plates of the capacitor, it can be written as Q by C. If we talk about the electric field, it can be written as V by D, or it can also be written as Q by A epsilon naught, which we have studied. And the energy stored in the capacitor, here we can write Q square by 2C rather than half CV square. I can also use half CV square, but rather than using that, I am using Q square by 2C because I know as no battery is there, charge remains constant onto it. So before insertion, if we talk about the parameters, these are capacitance, charge, potential difference, electric field, and the energy. Now in this situation, if we talk about these parameters, after insertion of dielectric, you know well that the capacitance will change from C to Kc because the dielectric is inserted. We talk about the charge, it will remain same. There won't be any effect on the charge because no battery is available over here to change the charge. If the charge remains same and capacitance changes to Kc, here you can see V will change to V by K because in denominator C will change to Kc and numerator will remain same. And here we can see electric field is V by D. D remains constant, D is not changing. But V changes to V by K, then we can see that electric field will change from E to E by K. If we talk about the energy stored in the capacitor, it is Q square by 2C. In this situation, charge is not changing on insertion of dielectric, but C is changing from C to Kc. We know this will change to Kc if K is the dielectric constant of the slab. So this will change from U to U by K. So you must be careful about these variation in the parameters, as all these are quite useful for different kind of numerical problems.